morning. Welcome. Welcome to AI Pulse. Welcome to Station F. I'm so impressed. This year they added some seats. Wow, and it's packed. No, thank you for coming. You will not have to support for long my bad English accent because Aude will come now. Aude, come with me, save me.
It is packed, you're right.
Yeah, my God.
I think we have over 2,000 people. Look everywhere, it's full. And then we have many more tuning in on the live stream from Berlin, Barcelona, Warsaw, Stockholm, and everywhere. It's amazing. Such a vibrant AI ecosystem. And it grows stronger every year, don't you think?
Yeah.
Well, actually, our goal today is to bring you the most exciting lineup. I think we have amazing speakers coming up. And as usual, our goal is to offer you the most expert content from star scientists in cutting-edge labs to CEOs, CTOs of startups that are building breakthrough tech, and even specialists implementing new use cases for AI across every industry every day. So much has happened in the last year, and there's definitely more to come. And today we'll explore where AI is truly heading in 2026 and beyond. And I think together with our speakers, we're here to say that Europe has every reason to be optimistic about its future in AI, don't you think?
That's amazing. That's a big change.
Last year, we emphasized the major role of open source in AI. And I think it's safe to say that the proliferation of open source models in 2025 clearly lived up to our expectations. Actually, today, Scaleway's customers' #1 used model is Qwen, the famous open source reasoning model. But this year, even though we'll talk again about open source, we're shifting the spotlight to the next frontier. So during our morning session and the afternoon technical panels, we'll look at AI through 3 lenses: smarter, faster, and everywhere. First up, AI is getting smarter, right? Everyone's pushing for AI to act as an agent rather than a chatbot, to go from information gathering to more reasoning with context, adding actions and planning, and hoping that AI will understand the consequences of those actions. Today, we'll see where we're at and where we're heading on this topic. Next up, AI is getting faster. This isn't news, but I'll give you one particular example that most of you in the room can relate with. This year has been the year where AI has changed the way that we build software. Some of you were a software developer a long time ago. Can you imagine now? Developers are going from writing code to actually orchestrating AI agents. And I know that for a lot of you here, understanding where AI is at every day has become a core part of your daily job. So AI isn't just helping us build faster, it's actually redefining what building is. And finally, AI is now everywhere. This is the biggest shift. AI is no longer confined to screens or cloud endpoints. It's entering the environments where we live and work. It's everywhere through advanced interfaces, through speech-native interactions, embedded systems, robots. And I think it's time to embrace the fact that AI is everywhere around us. But to embrace it, we first need to understand it. And that's what AI Pulse is all about. Before we start, I just want to say that none of this would be possible without our partners. So we'd like to take a moment to thank most of them, AMD, Ampere, Gigabyte, NVIDIA Module. I can't cite everyone, but thank you so much for supporting us. And now, without further ado, the moment you're all waiting for, let's dig right into the hottest topic today: how AI is moving from predicting words to actually understanding the world. AI that doesn't just process information, but simulates environments, dynamics, actions, and consequences. This is the promise of world models. So let's deep dive into the future with one of the godfathers of AI. He won the Turing Award. He's a Silver Professor at New York University. He's published hundreds of research papers, I hope you read them all, that have shaped modern machine learning. And he was chief AI scientist at Meta until very, very recently. We hope he'll tell us a little bit more about his next project. Who do you think this is?
No, I wanted to come this morning to say Yann LeCun is amazing. He's an amazing guy. So he's the best. Well, he's the best in the world for talking about AI. The first time I talked with him about AI was, I don't know, 10 years ago. At the same time, so he's the most clever in this industry, and at the same time, he's the nicest guy in the world. Every time we call him to help, he's always here. When we created 2 years ago Qt, he was the first one to help. And each time you have a new project, new startups, you can call him. He's happy to help, to find the talents, and to give the energy to these people. And so I'm so happy.
So does he help you understand AI?
Yes.
Oh, great.
I'm not sure.
Perfect. Well then, join me and everyone in welcoming on stage none other than Yann LeCun. Thank you. Thank you for being here with us. How does it feel to be back in Paris?
Oh, it feels great. You know, I come to Paris pretty regularly, but you know, it feels like home.
Well, great. You can please have a seat. And for this fascinating conversation on world models, we will introduce another speaker, a rising star in the field. His background is in engineering, but also he spent 3 years at Médecins Sans Frontières. He's the co-founder and former CEO of Metal, a platform that enabled him to build a priceless data set of video game interactions. In fact, OpenAI offered him $500 million for this data set. But he and his co-founders declined. They understood the true potential of this data, and they built their own NeoLab instead. So let's give a warm welcome to the co-founder and CEO of General Intuition, Pim de Wit. Thank you for being here. Thank you both for joining us today. We're so happy to have you. So one thing that you've both been talking about is world models, and long before it became the topic of the year. For many researchers, they finally realized that it's a next step when they realized that scaling language alone would never get us to actual intelligence. Yann, when did it become clear to you that LLMs would not be enough?
Well, this idea of world model is, you know, very old. I started advertising the fact that this would be the path towards progress in AI about 10 years ago. I was thinking about it for much longer. But I gave a keynote at NeurIPS in 2016, where this was kind of my main theme. I said, this is what we need to work on. And then it took me another 5 years, perhaps, to figure out that you could not do it with generative models. And you know, started kind of developing another approach, non-generative, that we call JEPA, Joint Embedding Predictive Architecture. And then LLMs came out, and they are generative. And I said, like, OK, this is interesting. You can do language with this. It's very useful. We should work on this. Lots of applications. But this is not a path to human-level intelligence, or whatever you want to call this. And this was so this predates the emergence of LLM, really.
And maybe can you tell us what is the limitation in itself of text in terms of compressing data? I think you have a very good way of putting this.
Well, so you know, think about like how all of us, or your cat or your dog, thinks about the world, right? As humans, we think language is essential to intelligence, but in fact, it's not. It's useful, no question. But animals are pretty smart. They're much smarter than the best robots that we have today. They understand the world really well. And it turns out understanding the physical world is much more difficult than understanding language. It might seem surprising, but it's really the case. And in fact, roboticists have known this for a very long time. Hans Moravec, a pretty famous roboticist in the late 80s, said, how is it that we can solve complex problems with computers, with AI, like playing chess and things of that type. But we still can't get a robot to kind of navigate without bumping into obstacles or to grab objects and things like this. We made a lot of progress along those lines in recent years, but it's still the case that we have our best AI systems can pass the bar exam, compose poetry, win international math Olympiads, and solve equations, all kinds of stuff, right? Write code really well, very useful. But we still don't have a robot that can do what a 5-year-old or a 6-year-old can do. And we certainly don't have robots that can learn to drive in a dozen hours of practice like any teenager. So, clearly we're missing something big. And when we think we have mental models of the situation that we manipulate, and we have physical intuition, and most of that we learn when we are babies in the first few months of life, mostly by observation of the world, but also by interaction. So this is the type of learning that I've been working on trying to reproduce for the last 10 years, failing for the first 5, and making significant progress over the last 5, roughly, using those non-generative architectures.
Okay. Maybe, Pim, can you tell us why? I think a lot of people were thinking that the next step after language models, introducing audio, would have been to include video, simply. And it's interesting that you're not working on video, you're working on video game data sets. Can you explain to us why this shift, why we don't need the video and why we need something else?
Yeah, I think video is really important, right? So to understand the world, it's really like the best representation that we have. But the way I like to think about it is, think about when you dream. Often when you dream, you can't really interact with what you're seeing. You're kind of a bystander in the dream, right? And the way that humans learn is fundamentally very interactive. So, and you need a lot. So in a video model, you might predict, for example, the next frame, or the next likely or entertaining frame. But a world model has to generate the entire distribution of possible outcomes based on the actions that you take. And so for world models, and in particular, we train agents inside of world models. You need a lot of action and interaction data on top of the video representations to build these world models. The way I like to maybe intuitively explain is, who here has seen the movie Frozen? Okay, a lot of people, great. So LLMs are a little bit like snowballs. So they go down the slope and they accumulate snow, right? They're autoregressive, so they take the output of the model and then they run it through the model again and they predict the next token. And they have no perception, so it will just keep rolling and rolling and rolling and rolling, and as it comes to the bottom of the mountain, it doesn't know that it's about to crash into something because its entire world is just itself, right? And so real intelligence is more like Olaf. Like Olaf would know if there's a stone, right, to break up and dodge the stone. And so text is fundamentally very, very limiting in that like the world we perceive is the text is a small component. It's a compressed component that we as humans invented, our three-dimensional perception, to actually describe the world. But really, in world models and with agents, you need to be able to interact to build a general intuition of the environments that you operate in.
Yeah, that's an really important point you're just making. If you have a mental model of the situation you're apprehending, that allows you to plan, right? I mean, the main purpose for building world models is to build what's called action-conditioned world model. So something that says, here is the state of the world at time t, here is an action I imagine taking or an intervention. Can I predict the state of the world that will result from taking this action? And if I have such a model, I can imagine the outcome of a sequence of actions and then optimize the sequence of actions to accomplish a particular task, satisfy a particular goal, perhaps subject to safety constraints or things like this. So this is kind of a new way of building agentic systems, but not just agentic systems. So it turns out agentic systems don't really work that well at the moment, right? People use LLMs to basically train systems to produce sequences of actions. And that requires a huge amount of data because you need to train those systems through essentially behavior cloning or imitation learning from human data. And that's only practical for a small number of applications. And in the end, it's not very reliable because those things behave like a snowball, as you said. I love this analogy. So you need a system to be able to predict what's going to happen in the world and what's going to happen as a consequence of its actions. And that's really what a world model provides. So it's really a completely new blueprint for AI systems. And the company I'm creating is really focusing on this, basically building the next generation AI systems that will have those capabilities. And it's completely orthogonal to what LLMs are doing. Those systems will deal with data that is high-dimensional, continuous, noisy, all things that LLMs really can't deal with. And so it's a new generation of AI system where, there is some people who claim that we're just going to scale up current technology and get to human-level intelligence. I've always thought that was BS, if you pardon my French. But we have a good chance of making significant progress over the next few years by changing the paradigm.
It's maybe worth noting also that these world models, they can also be text conditioned, right? So you're not necessarily stuck in one paradigm or the other.
Absolutely.
As developers of world models, we can actually import a lot of the work that's been done in the text domain and help them to enhance our models as well and help them build a richer understanding.
Oh, that's a great bridge to my next question, because we're saying it's a new blueprint and it's an entirely new paradigm. What is actually going to change fundamentally in those architectures? And I know that this audience has a mixed level in terms of engineering and science, but can you maybe try to explain it to everyone?
Well, so there's a lot of, our society is, relies on communication between people, and because a lot of what we think of our human knowledge is reflected in text, we might think that all of our knowledge is actually reflected in text, but that's just not true. Most of human knowledge is not well represented by text. Most of human knowledge is mental models and intuition about the physical world or situations that are not text-related, right? So thoughts occur inside of our minds, not in terms of tokens. It's in terms of mental imagery and various other things. So we'd like AI systems to be able to do this. Now, in terms of the practical applications, there are two types of applications of AI today. There's the applications that LLMs can deal with, which mostly has to do with language or discrete sequences of symbols. But then there is, the other type of AI that, to some extent, is older for perception, for example, visual recognition, speech recognition. Speech recognition, we have good examples here. People doing dialogue systems. But most of the data in the world, particularly now in our digital world, is high-dimensional, continuous, noisy. Think about, you are an industry manufacturer. Let's say you build turbojets, okay? Airplane engines. A turbojet engine has 1,000 sensors. But nobody has a complete phenomenological model of what a turbojet can do. There is, local small models that are built for particular aspects of it, but there's no complete model of that turbojet. Think about a steel mill or some, manufacturing plant, or a robot. Robot has a lot of sensors, vision sensors, touch sensors, proprioception, and then the environment is really complicated. How do you build a model of not just the robot itself, but its interaction with the environment and models of the environment? And so that, there's a whole world of applications that could open if we had AI technology that was capable of dealing with this kind of data. And that's basically what I've been working on for the last many years and made quite a lot of progress over the last few years, to the point that it was really time to kind of switch to high gear and really push this technology outside, which is why I'm creating this company. I can't tell you much more about this today. There'll be more information about what we're working on in January, but it's on a good path.
Great. But so maybe from an engineer's perspective, to maybe answer the questions of the developers and engineers in the room who are thinking, how am I going to integrate this in the use cases that I'm trying to build today? What can you say to them to prepare for the future?
I think it's time we start understanding the world of pixels as well as we understand the world of code and the world of text. And so, learning how like video encoders work, learning how really build an intuitive understanding with tools like FFmpeg for like large-scale video processing, data infrastructure, like generating embeddings from video data. Like all these are like pretty interesting problems that are actually like still quite hard and unsolved for different areas. And so there's lots of opportunity. And I think also what's interesting is I'm really curious personally. So if you think about all the text data that went into LLMs, every single piece of data is something a human said about how they perceive the world. When you actually train these models in perception, so in like a first-person view, you have like a very different level of abstraction that is actually a much more accurate way of how people actually perceive the world versus how they described it. I kind of describe it as like described reality versus perceived reality. And so I'm just also really, really curious about the developer applications that are going to be possible once you actually have models that are trained fully in perception.
Yeah, this question of being able to having AI systems or machine learning systems that are capable of learning abstract representations of the observations that they're making is crucial to handling data like video. Yep. It's not absolutely necessary for text, and I mean, it is necessary, but you can get away without doing it for text. And the reason being that text can be predicted because it's discrete. It's easy to basically predict the words that follow a sequence of words. You can never exactly make exact predictions, but you can predict a probability distribution over sequences of words, right, which is what LLMs are doing. You cannot do this with video. You cannot train a system to predict at the pixel level what occurs in a video, because most of the details are completely unpredictable. If I take a video of this room, and I start from here and pan the camera, and I stop here, and I ask a video prediction system, tell me what the rest of the room looks like. Of course, it can predict that there's going to be people sitting and probably a wall at some point. There's absolutely no way it can predict what every one of you looks like. That's just impossible, right? And so if you train a generative model to predict at the pixel level to do video prediction, you get nothing interesting. Yeah. And in fact, we have a lot of empirical evidence that when you compare generative architectures with non-generative one, those joint embedding architectures, for representing images or video or other signals, the non-generative one win every time for self-supervised learning. So that's really the way to go. Now, what's happening is Silicon Valley is completely hypnotized by generative models. And so you have to do this kind of work outside Silicon Valley, in Paris.
Yeah, I got started in this line of work largely because learning from your lectures, and so it's very, very important work. And I think for me, as somebody like I got started fairly recently compared to a lot of you here. Having people like Jan who are willing to speak their mind despite kind of the very loud microphones of people on the West Coast of America is really special. There's not many, so thank you. Yeah.
Thank you.
Thank you. Well, it's actually interesting that both of you chose to go into this field of world models through new independent labs. And so I'm curious why you chose to do this and what are going to be the resources you need, the talents, the infrastructure, and maybe where this could be the best place to start this.
Well, okay, so I have to tell you that this project that we call AMI, in fact, in French, Advanced Machine Intelligence. This project of building this kind of AI systems with this new architecture is a project that Mark Zuckerberg really likes. He thinks maybe that's the future. But what's happened over the last several months is that he and I both realized that the potential spectrum of applications of this was kind of beyond what Meta was interested in. So it became clear to me that it was the right time to basically make an independent organization. Meta is a partner, it's not an investor, but a partner, because they're interested in some of the results from that research and development. But the number of applications is so wide that it was better to do it as an independent entity, and also a global entity, in the sense that having research organizations everywhere around the world, particularly in Europe, where there is a lot of talents, which I think currently does not perhaps realize its full potential, and so providing the environment for this, I think, is essential.
Yeah, and Pim, I think you're from the Netherlands.
Yep.
So it was dear to you to come back to Europe and try to build this here. What are you going to need to succeed?
Yeah, I think it's very, very true that a lot of the talent for world modeling is in Europe. I think a lot of that is due to the work that you did at FAIR and how you educated people, and DeepMind also did a very, very good job investing in this type of research early. So as for us, like it's been much easier to find great people who are here with us today in Europe than it has been in the US. And I think to your point, I do find that in the US, there's still a lot of people that are very like LLM pilled. But it is just very true that we need something else. And I think people are more understanding of that here than in the US. And I think in the US, it's also quite interesting. There's a very different mentality when it comes to scaling research, right? I think, and so they are very much in like the scale LLMs as far as you can, and the quote unquote snowball is rolling, and it's hard to stop, right? And I think, which is a great time for us to go do some fundamental research, and luckily in our case with tons of data, and get to push the frontier hopefully in a way that is, one thing I'm excited about is we hopefully also get to do it in a way that's more open, in a way that I think LLM research kind of became more closed, and I think for us, one of the things we're also excited about is doing that.
And the funny thing is that it's easier to get large amounts of data for things like video than it is for text, right? So if you take all the publicly available text on the internet that most LLMs are trained on, it's on the order of 10 to the 14 bytes. 30 trillion tokens. That's the typical size of the pre-training data set for a typical LLM. You can get this from video very easily. You get 10 to the 14 bytes, even if you compress the video frame to low frame rate, maybe 1 megabyte per frame or something. 10 to the 14 bytes is 30 minutes of YouTube uploads. It's also the same amount of visual information that a 4-year-old has seen during his entire life. And so the video models that we've trained at Meta, VJPA2, for example, has been trained with something like 100 years of video, and you can get this easily. It's public data. So it's much easier to train on lots and lots of data if you deal with high-dimensional, continuous noisy signals than from text. It's just way more of it.
Yeah.
And of course, it's redundant. It's more redundant. But that says what you need for self-supervised learning. And then you can have action-conditioned video, which comes from games, or from simulations of robots, or from real data of people doing stuff in the world that you observe doing. And there's more and more data from that because of the appearance of smart glasses and other devices. So really, I think it's a richer world. It opens the door to a whole universe that AI currently really does not apprehend very well.
And I think there's a question about the compute resources that are going to be necessary for world models, because there are debates about is there enough infrastructure in Europe for AI? What's this going to look like, you think?
It's actually smaller. Like, the computation you need to train a model like, VJPA2 is, a few thousand GPUs. It's nothing like the gigantic scales that are required for, top-of-the-line LLMs. It's actually quite a bit smaller. So, you get the best of both worlds. You get more data, you can train smaller models, and in the end, they are smarter, and they have, some level of common sense. You can do the same for planning. I mean, it's a complete no-brainer.
For us, what's interesting is, so when you're a large lab that's starting off video data, you have to then also train labeling models to, for instance, generate, as John mentioned, like the action conditioning data. And for us, the reason why we are so compute efficient is because we have all those ground truth action labels already. So Metal does about 1 billion video uploads a year with these action labels already attached. So a lot of that compute for other labs would be going into labeling video, and we don't really have a lot of those costs, so we can go straight into predicting actions from the video data. And I think one thing that's maybe worth calling out is just for people listening here, maybe thinking about building businesses, there's a huge shortage of action data, of like ground truth action data that can be used to label videos. And I think outside of games, it's just very, very hard to get this data. So if people are thinking about building startups that want to reach out, that's very, very helpful. Do you have that? Do you see that too?
Yeah, I agree. Although it's changing quickly because, so you have smart glasses. So Meta is kind of a big proponent of this, right? And there's data that has been collected. It's still being collected of people just doing everyday tasks and then kind of filming what they're doing. And it's not a huge amount of data. You can, spend the money to have this labeled. So if you have a two-phase training procedure where you first train a system self-supervised with unlabeled data to just understand video, right? And then on top of it, once you have good representation of video, you train a small head on top of it to do action classification or action prediction. It actually works quite well. In fact, we have demos of this internally, and this is pretty cool.
Yeah, that's maybe worth mentioning about JEPA, that it is really a foundation that can even be used for world models of all types, right? And that's also why it's so important. And yeah.
You touched upon it a few minutes ago, but both of you are strong advocates for open source. And so I was wondering if open source will also be an enabler for world models and how you think you're going to integrate this in your companies.
Yeah, absolutely. I've been a big proponent for open source for a long time, as many of you know. And I think what we are observing at the moment is the big American player in the domain are kind of climbing up. OpenAI, of course, has stopped being open quite a long time ago. Anthropic never was. Google is kind of somewhere in between, but mostly climbing up too. And Meta is kind of, a little bit kind of rethinking its strategy about open source. There's still going to be quite a lot of open source coming out of Meta, but maybe not as sort of systematic as it used to be. And so, conversely, what you're observing is that China, on the other hand, is going open source all the way. So the best open source models at the moment in the LLM world are all Chinese, and it's not good. You need models that are, easily modifiable, but not necessarily kind of preconditioned to conform to, the political view of the Chinese government. So there's a lot of resistance from a lot of people to use Chinese models for that reason. So I think, so that's one point. That's kind of the geopolitical point, if you want. There's another important point, which is the reason why AI has progressed so fast in the last few years, the last decade, the last 15 years, is because of open source, because of quick open publications, and because of open source. And Meta Fair kind of pushed this model quite a bit and caused other labs like DeepMind to actually become more open as a consequence. It wasn't that open before, but it had to, because that was, open research is the best way to make fast progress, first of all, and then it's also the best way to attract the best scientists. If you try to hire scientists and tell them you can't say a word of what you're doing, you don't attract the best. Now, we are on the cusp of a new revolution, and we need contributions from everywhere, everybody around the world. If you type on Google Scholar, between double quotes, joint embedding predictive architecture, okay, all spelled out, you get 900 hits. The concept was already only published maybe 3 or 4 years ago, but already there is 900 papers on that topic, most of them not from people working with me. People are trying to use this for all kinds of stuff. And
we were probably trying to, we'll probably use it too.
Yeah, exactly. So we need contributions from everyone to make this, to push this forward. And open source is the best way to do this. Now, of course, when you are in a company, particularly a startup, there are things you open source and things you don't open source. So things that is, more upstream, more conceptual, more algorithms, prototypes, that's open source. That's part of research. And then things that are kind of downstream of this, which is how do you push this into product and technology transfer, maybe that's not. That's okay.
And maybe to give a concrete example of collaboration between labs and going towards open science and open source, something that's going to relate to both of you, because Jan, you're a scientific advisor to Qt. We just announced last week that there's going to be a brand new partnership between your team, Pim, and Qt. We're super excited about this important scientific collaboration. Can you tell us about the synergies between Qt and General Intuition, and what's your ambition behind this?
Yeah, so for us, I think LLM companies don't have much of a moat because all the text data on the internet is very, very openly available. And so for us, we're really excited to do a ton of open research, but we also need to be very focused as a team on our customers. And so, we partner with Qt to make really the first data set of this size available for research, and we're working on some of the foundational blocks of world models. So we'll share a bit more about that soon with the team here in Paris. And so, think about that similarly to how Jan publishes very openly about JEP, but we'll be very, very open about publishing some of these foundational blocks with Qt.
Okay, so to sum up, the future of AI is probably in word models. We have everything we need to in Europe to do this, and we're looking forward to more collaboration between all of your labs. Thank you so much.
Yeah.
Thank you.
Thank you for being with us. And I'll definitely remember the Frozen analogy and to explain war models to all children.
Hopefully AI also likes warm hugs.
Thank you.
All right. Thanks, everyone.
It was great having you. Thank you so much. Wow, I hope that you enjoyed this panel debate as much as I did. Maybe I just need a minute for, breathing, because I have to admit that even after 3 years, standing in front of all of you and interviewing such incredible speakers still makes me a little nervous, let's be honest. So perhaps I can slow down.
It's going to be fine. No worries. I can hold your hand while you speak. Everything's going to be fine. Would that make you less nervous? I can hold your hand while you speak. Would that make you less nervous?
I'm sorry? You're offering to hold my hand? That's very kind, but no thanks.
That's okay. We can try something else. How about a tiny warm-up with me instead? Just follow my hands like a mirror. Let's wake up our bodies together and wake up the audience.
Well, it sounds tempting, but no thanks, I'll pass.
Oh, okay. Seriously? Emotional support is part of my design. I help kids through stressful medical procedures. Most people love me. Don't you?
Well, sorry, but who are you anyway?
I'm a Mirakai. I'm designed to help humans, and I'm made in France. I can also read emotions. You look anxious.
Brilliant, thank you. Actually, when I think about it, I think I've heard about your kind.
Really? What are your sources?
Well, I read scientific papers, I watch the news, and I also watch Black Mirror, so beware, I know what you're capable of.
Oh, no. Look at me. I'm not HAL 9000. I'm sassy but friendly. I'm cute. I roll on a ball. That's it. No world domination protocols. The worst I can do is roll over someone's foot. Just kidding.
All right, well, relax. I was messing with you too.
Oh, that's not funny. Humans really need to chill out about robot anxiety. I offer to hold your hand, and you think I'm Skynet.
All right. Sorry, little one. But I think it's time to make way again and get back on track. So we've discussed world models as the future of AI, one of the necessary steps towards robotic. And I'd like to introduce you to some of Europe's most brilliant minds in the field. So maybe next we can welcome...
Yes, beam up the brilliant minds, Scotty.
OK, so you're staying here.
Of course. So many great keynotes incoming.
Well, that's very sweet, but maybe you could make room for the speakers now?
Time to go. See
Yeah.
ya.
Come on, bye-bye. Yay, see you around. Thanks, this was Mirokai. Well, after such a performance, I think I have to introduce you to one of Mirokai's creators. Let's welcome the CEO of Enchanted Tools, Jérôme Monceau.
Left arm.
Hello, Jérôme.
Hello.
Thank you for being here. Jérôme, you're best known for co-founding Aldebaran Robotics and leading the creation of some iconic social robots like Nao and Pepper. And actually, I learned that Aldebaran is still to this day the largest producer of humanoid robots in the world.
Yeah.
In 2021, you founded Enchanted Tools, which is a deep tech startup blending robotics, AI, and 3D character design to build enchanted humanoid robots like the one we just saw. Thanks for joining us today.
Pleasure.
Jan and Pim just talked about world models being a tool for the future of robotics. Could you maybe tell us a bit more about the technology that currently powers Mirokai and where you see this going?
Yes, sure. Thank you a lot for welcoming me today. And as you said, I'm doing humanoid robotics with my team since something like 20 years, and we learn a lot by deploying robots in the real life, how people react, what they want, what they expect. And that's why we try to design something that is safe all the time, very fluent in the way it moves. So that's why we didn't decide for bipedal robots. It's also a cute face that people enjoy, friendly, and we design also a set of accessories all around that make things easier for the user. And we are a trusted partner of Google DeepMind, so this means that we can use Gemini Live and Gemini for Robotics, which provide to the robot an analysis, a multimodal analysis of the scene and help to synthesize behavior. And we also have machine learning, some models running on board in order to deal with the proximity of the people. So you should know that we are about to have 50 robots on the field deployed in hospital, in healthcare, and for us, user is key. We can not just provide a robot like this and expect people to know how to use it. We should design a dance between the user and the robots.
Okay. And so maybe for the people who want to learn more about really the tech that's behind this robot, there's a panel with the CTO of Enchanted Tools this afternoon at 4 p.m. If you are hands-on in robotics. Maybe to come back on what you were saying about reacting with humans, you often say that robots should not just react, they should also anticipate humans' next move. And so I'm curious what makes anticipation so hard in developing robots.
Yeah, in the way we are addressing the market, user is at the center, and there's many social codes that are really complex to manage. If I give you an object, your smile, the way you look, the way you move, when I can release the object, is something that has been coded, and we should know this when we want to design a successful humanoid social robots. And our users are kids, grandma, nurses, caregivers, and they don't know anything about the technology we are developing. So we need to find ways to make things easier and very intuitive and not scaring them. We must understand part of the psychology of the user.
Right. Well, I think that what's interesting with Mirokai, it's not the typical industrial robot. It's not made for heavy lifting in a warehouse. It's made to interact with people in challenging environments. Maybe can you tell us more about the empathy component of this?
So this robot has been designed to assist on poor staff. The people who are working in elderly homes, hospitals, which are under stress, that place are under stress. We all know that. And in the way we design the robot, we should make the robot very transparent in what he wants to do and very clear about what he can do and what he cannot do. Because we cannot pretend doing something and with 80% of success, because the 20% of success is failure. And failure in healthcare, that's a big issue. And you know, we decide to go for the hospital, obviously for the impact, because there is a big impact there, we know. It's also because this is a semi-standardized space. We know the nature of the floor, we know the size of the corridor, we know the door weight, the colors, the light, the people, the roles, the regulation. So it makes it easier to integrate this robot safely and in a very understandable way for the user.
Okay. And I think a lot of people think about, where do I find the ROI with the robots, and especially if I'm doing an emotional robot, how is this going to work? You told me about a particular project that you have underway about helping kids with cancer. Can you talk a bit more about this? Because I think it explains so well what the value can be behind this.
Yeah, I love this example because it shows that emotion could have a very productive impact. So that example is ICM, which is the Institute of Concert at Montpellier. So they are welcoming kids every day to enter the bunker with the radiotherapy ray, you know. Kids are attached on the table, that's horrible. And they don't like this. Usually they need to sedate the kid in order to get in that room. And a doctor there, people there understand that what is missing the kid is a presence inside the bunker. But the parent could not enter, the doctor could not enter.
It's too dangerous for any other human.
That's why they bought our robots, and we are working with them. And we have been, we get the approval of deploying our robot inside the bunker. Because of the ray, we have to make sure that everything is clean. But what we know now is what was before something that was long, 60 minutes, and full of pain and so on, become a moment of joy because they are not alone, there is a robot. And we have a 10x factor in the productivity of the machine. And of course, the well-being of the kids, the parents, doctor. And,
they don't need to be sedated anymore because they're not worried anymore.
That's a good news.
Which is amazing,
very good news.
right?
Yeah.
Sounds great. Well, maybe to wrap up, you've been working on social robotics for years now. Where do you see the future in this field going? Yeah,
for me, humanoid robots, it's about human. Yeah, they are designed to evolve in place where we are evolving. So the point in the way we design them is not only to be able to just function, it's also to be able to integrate that there is people and they are living something. You know, we don't want to build elderly houses that is just about utility. We want to build a life experience in that place, in a shop, in elderly care, in hospital, in pediatric hospital. That's the kind of things that humanoid robotic can do. It can bring utility, joy, marvel.
Great, that sounds amazing. Well, then we wish you best of luck to you and to Mirakai. Thank you so much.
Thank you.
A very inspiring use case indeed. Yeah, over there.
Over there, okay.
Sorry. All right, I think in this room we have plenty of AI builders, and so we know that one of the things you know to build AI are platforms and infrastructure. At Scaleway, we're incredibly proud to support this ecosystem by offering secure and easy cloud access to the best of AI technology. So now I think it's time for a quick look back on 2025 and, most importantly, what we have in store for you for next year. Please join me in welcoming the CEO of Scaleway, Damien Lucas.
It's another exciting edition of AI Pulse. Europe is truly at the cutting edge of innovation, world models, robotics, and much more. At Scaleway, we're committed to making those innovations accessible to you. In the past edition of AI Pulse, we brought you plenty of innovative services and you built fantastic services and applications on top of it. Congratulations. Scaleway is all about providing the best AI infrastructure in Europe. And we keep expanding. On top of France, the Netherlands, and Poland, we're deploying our products in Italy, Sweden, and soon Germany. When I say our products, I mean the whole product portfolio. And that product portfolio is growing every day. Remember, last year at AI Pulse, Michael Dell, on this stage, explained that we should bring AI to the data, not the other way around. Bring AI to the data. And that's what we made possible. On the data side, we've expanded our product portfolio by acquiring Sagi and making a lot of products available, such as Kafka, OpenSearch, Data Warehouse, Data Orchestration, and many more, all available in our cloud. On the AI side, we know compute is very important. It is critical. So we have released brand new AMD CPUs, a brand new offer based on ARM CPUs from our partner Ampere, and we're exploring the future Fujitsu CPUs. Speaking of brand new hardware, brand new and futuristic hardware, I would like to take a moment to talk about quantum computing. Remember, 2 years ago, during AI Pulse, we were the first to introduce quantum as a service, quantum in the cloud. At that moment, the technology was not ready, and what we were offering was quantum emulation. And what was the goal? The goal was very simple. Let the researchers explore quantum algorithm before hardware becomes available. Then last year, we announced our partnership with Candela, and we released real QPUs, quantum processing units, available in Scaleway. And that was based on Photon technology. And Photon, that's perfect for AI workflows. It's perfect also for optimization tasks. But when it comes to quantum computing, this is not one size fits all. There are different hardware technologies that can solve different types of problems. That's why this year we're announcing 2 new partnerships with European European quantum leaders. Pascal and their neutral atom systems, and IQM and their superconducting technology. Neutral atom systems, they excel at solving massive combinatorial challenges that traditional computers struggle with. And superconducting is the best choice for financial modeling or running deep general-purpose algorithms. To make those technologies easy to use, we have integrated them with the top open source frameworks. So we got photonic, we got atomic, we've got superconducting, all of these technologies available on Scaleway Quantum as a Service right now. We're so proud to be the leading platform for quantum computing in Europe. So, CPU, QPUs, what's missing? GPUs. I know you love GPUs. And at Scaleway, we're committed to providing a wide range of NVIDIA GPUs. Today, we're proud to announce that the very latest NVIDIA GPUs are available on Scaleway Cloud. Blackwell Ultra B300. They are 50% faster than the B200, and they are the first in Europe in Scaleway Cloud available today. so much. Of course, energy consumption is top of mind for so many of us today. That's why we expanded our environmental footprint calculator to GPU products, so that we can help you understand the true impact of your AI workflows. Because at Scaleway, transparency matters. But how are we going to use those GPUs? Not everybody wants to use raw hardware. With AI everywhere, a lot of you are looking for easy-to-use models as a service. And for that, we have two products for enterprises and for developers. We have a dedicated product offering extra security requirements, and we have a mutualized product with more flexibility and elasticity. And all of you, AI builders and innovators, you need the right models for your use cases. So we're offering state-of-the-art open-weight model, and we've integrated with plenty of models. For text, we've integrated with GPT-OSS, with Qwen 3, with DeepSeek R1. For audio, we let you access Whisper, Voxtron. For code, obviously, you can use Qwen 3 Coder on Scaleway. For vision, you have access to Gemma and Mistral Small. That's a lot, but we still want to provide even more. And we've also expanded our catalog of models through a partnership with Hugging Face. 3 months ago, we became their first European sovereign inference provider. You have now access to thousands of open source models deployable on Scaleway in a click. And yes, we love open source. But you ask for the best frontier models, and not all of them are open source. So we've partnered with your favorite European AI labs. What about agentic AI? Maybe you remember, last year, on this stage, we announced that H was created and started training their model on Scaleway infrastructure. A year later, they released their second model, Holo 2. It outperformed all open-weight models in a very important area: understanding and navigating user interfaces. And because the web and our smartphones are still based on user interfaces, having a model that can browse them is critical to build useful agents. Imagine an AI that can interact with your enterprise software, with any application, without having to integrate with complex APIs. We're super proud to announce that this brand new model is now available on Scaleway, and we're the first cloud provider to offer this model. Mistral, they began their journey by training their model on Scaleway as well. It was 2 years ago, at AI Pulse as well. I'm sure you remember that. It was the first edition. Now we're expanding this partnership. You can now use their models as a service, but you can also use their full enterprise suite, AI Studio, to build custom workflows, Mistral Code, to accelerate software development, and Document AI to automate document processing. This marks a new win-win for Europe, top European AI companies working together. And for Europe to succeed, we need to dream bigger. We need to keep building AI factories and gigafactories. That's why we've put together a consortium to build this massive infrastructure. It's called ION. So you can get the best of AI locally, right here in Europe. It's going to take hundreds of thousands of GPUs. And with our Aeon partners, we have the right expertise in all critical areas. To name a few, electricity with EDF, data centers with OpCore, use case implementation with Artifact and Soprasteria, models with Qt, H, and Hugging Face, and of course, GPU operation with Scaleway. Once again, Scaleway is leading the way.
Thank you, Damien. We're both so excited about this project. Thank you. Let's
Thank you.
hope that it takes life soon. All right. For the second part of this morning session, we wanted to highlight two of the hottest AI startups in Europe. Actually, they both announced their launches just earlier this week. Let's start with the new AI robotics company called UMA, launching from Paris and ready to take on the world. We're delighted to welcome UMA's CEO, Rémi Cadenne. Hi, Rémi. Thanks for joining us. All right. I think this is a bit of news for everyone, so maybe let's start by telling us more about this launch and your ambition for UMA.
So, yes, thanks. I'm super glad to be here. The launch was incredible. We had a very big visibility worldwide. Even my friends in Silicon Valley were messaging me, seeing UMA over the news, so incredible. And I'm grateful for all the support, all the energy, and yeah, all the visibility worldwide.
So what is it that you pitch to your investors?
Yeah.
What's your objective?
So UMA stands for Universal Mechanical Assistant. And we build general purpose, mobile and humanoid robots powered by the latest AI revolution and technologies. And our ambition is to make work safer, more fulfilling, to drive economic growth, and to improve quality of life for everyone.
Okay.
The big mission.
Well, you're not coming to robotics from nothing. Maybe to say a bit more about your background, you worked on robotics at Hugging Face previously, and then before that, you even worked at Tesla. You're a part of the team developing the AI stack for Tesla's Autopilot, and then on the team developing their humanoid robot, Optimus. What lessons do you think that you've applied from self-driving cars that apply surprisingly well to humanoid robots?
Yeah, so many lessons. Actually, driving is a subset of the human behavior. So it's extremely social. You interact on the road with a lot of people. Every day, you need to handle some very complex situation, and you don't just follow the rules. There are always edge cases. And you need to take very fast decisions. So it's a super difficult problem. And we reach a point where we develop a technology so general that it can be applied to self-driving, but also to humanoid robots, learning from people. And so it's very difficult, but now it's beginning to be possible. Like self-driving is an example. In Silicon Valley, you have self-driving cars all over. A lot of people are using it, and even the latest studies shows that it reduced mortality on the road in the US where they were deployed. So it's starting to be possible.
And so what's the key to have humans and robots work together smoothly and be safe at the same time?
Yeah. So the key is so first, in terms of AI, we need to learn from human data. So for self-driving, we had a lot of data available, and that's how we were able to handle the edge cases Then you need a super robust hardware stack with very fast ability to predict and so on. For robotics, you also need to develop a body which is lightweight, which is safe by design, which has the sensors to handle all the complexity of the world, and you need to learn from human intent as well. So yeah.
And so if you had to pick, what's the hardest challenge in general purpose robotics today? Is it dexterity, vision, human interaction, and maybe what's your team bringing to these problems?
Yeah. So the most difficult challenge to me is dexterity.
Okay.
So we don't realize how incredible our own hands are. So we are able to be extremely dexterous, to manipulate very thin objects, to manipulate eggs, to not crush the eggs. So we need sensors. You need to, and we are also able to manipulate a diversity of objects, of grasp. So we constantly improve our way of our gesture, and we don't even need to think about it. And we need to develop the same thing for robots.
And I think you have one really great expert on the team, right?
Exactly. So I'm very lucky because one of my co-founders is Rob Knight, and he has been developing hands, robotics hands, all his life. Like even before university, actually. And he has open sourced the most dexterous and affordable version of hands. So we take this problem very seriously, and yeah, I'm very looking forward.
Okay, so you're also an advocate of open source.
Exactly. Yeah, I've been working on open source since my PhD at Sorbonne, and also recently at Hugging Face on Le Robot, which became the go-to library for robot learning.
Okay. I think in one of the things you described to me as the way you're going to attack this, one of the things that struck me is that even though we know that a lot of robotics demos today can't really handle the messiness of real life, they're just demos, you're going to try to tackle self-improving robotic intelligence as a path to robustness. Sorry. Can you maybe elaborate a little bit on this?
Yeah, so we are seeing a lot of impressive demo of a few minutes. And they are improving at a very high pace. But most importantly, we are seeing now demo videos for hours of robots automating tasks in real-world environments. Tasks such as folding clothes, making a latte, folding a box for logistic, packing. And so it's becoming possible. Okay, so with no human intervention, fully autonomously. Then we've seen a robot walking for 100 kilometers for 3 days, even switching his own battery. Okay, a humanoid robot. So this is extremely difficult, and it's becoming possible. And also self-driving cars, operating for days, fully autonomously, and millions of cars. So I'm very impressed, and it announced a shift and a revolution in automation and robotics.
Okay, and your role is to work on the software side as an agnostic software, whatever their hardware, right?
So we are focused on software, AI, on the brain of the robots. And we have the ingredients to be able to learn from people and to have these self-improving robots that, like us, increase our ability to do tasks just by practicing. But in parallel, what's extremely important is that we also design our own hardware. And the reason why is that we are seeing an evolution in the robot design. We need robots that are safe by design, so lightweight, and that can be affordable, cost-efficient, produced at scale. And so this means that we need to own and control a supply chain, our own supply chain, in Europe for the European market.
That's a great bridge to my final question. Why did you choose to build your company in Europe?
We are convinced that Europe is the best market for this new technology. And that's something that not a lot of people are aware
Yeah,
of.
usually we talk about talents and resources. You say this is the best market.
And this is the best market, and we also have other advantage. But this is the best market because we, like in Europe, we have a historic industrial network. So we have a lot of companies doing in industry. And we have like very high qualified people, but an aging society. So there is a critical need for automation, and it's in the mind of all the C-levels in major companies doing business in Europe. So there is this. Then we have talents. We have incredible schools and universities at an affordable price. So personally, I paid 600 euros for my master degree, for 1 year of master degree.
Yeah, I'm
each
sure
year.
a lot of Americans envy
Yeah,
that.
exactly. So 600 euros. People don't realize how affordable the high quality, and I was at Sorbonne University, which is one of the best universities. So there is this. So we have a lot of talent spread out, but a lot of talent in all the cities in Europe.
All right, so you're joining the optimism around Europe with us. Thank you so much.
Yeah.
Well, we're very excited to see where your company's going, so we'll keep in touch. Thank you, Rémi.
Yeah, thank you.
Thank you. All right, our final guest today, last but not least, co-founded Qt and helped bring Moshi to life. You remember Moshi, the fully open source conversational agent that marked a turning point for voice AI. Our speaker has spent years pushing the boundaries of audio models, and today, he's taking one step further to bringing these technologies to mass adoption. Last Tuesday, he officially launched his new company. Please give a round of applause for the co-founder and CEO of Gradium, Neil Zeguido. Hi, Neil.
Merci.
Thanks for being here. You love
Thanks.
this stage, right?
2 years after the launch of Qt.
Exactly. Maybe can you start by telling us what's the purpose and ambition of Gradium?
So, Gradium is this new company we created to bring voice AI to the level that we think is going to be the way we interact with machines, which means having very qualitative, natural interactions.
And, well, sorry to be blunt, but when you say it like this, it sounds like it was very close to the purpose of Qt. So maybe can you explain what you're building on top of the research that was done in Qt?
Yes, so what we did at Qt, it was open research, which means that our goal was to make inventions that are scientific breakthrough. In particular, we did Moshi, the first real-time conversational AI. We did Hibiki, the first real-time speech-to-speech translation systems. And then an interesting thing happened is that we open sourced these models. We published our inventions. And our models were released with a commercial license. So the idea was that the community will take these models and create products around them. What happened was actually a bit different, is that we saw a lot of traction from the market, a lot of interest for these models, but they were not usable in production because they are prototypes. They were English only. They were not studio quality. You know, they had a lot of, basically there is the last mile between what is a good research prototype and what is an actual product. And Jan earlier also said, made this distinction between the fundamental inventions that can be shared in open source, but then pushing the limits of the latency, the quality, so that we can finally reach voice AI in products that feel natural, robust, fun, engaging, that's more the job of a company, because it's not only about making scientific breakthrough, but really pushing the level of details to the finest precision.
And so you brought together a team that is capable of creating this industry-grade audio models, right?
Yeah, so I'm creating Gradium with an outstanding team, with former colleagues of Qtile, with former colleagues of Google, and people who join us from elsewhere as well. And I think our identity is a bit different than a non-profit lab. It's really about making products that are competitive. So our ambition is pretty clear. Our thesis and our observation is the following. The potential of voice AI is not realized to even 1% of what it can. It's going to be the way we interact with machines. It's going to also mediate interaction between humans through natural translation, voice improvement, and so on and so forth. And the gap between where we are right now and what we want to get there is really about the technical limitations. So what we have assembled is a team of world experts in voice, building on also the inventions we made at Qtile to bring the best technology and keep pushing the best technology to put into products. So our positioning is that we are not making products for a specific vertical. We make the building blocks that are used by a lot of businesses to create voice agents and voice experience.
So maybe for all the businesses that are here today, what actually are your products? What does it look like?
So what we are, and what we announced only 3 months after creating the company is real-time transcription and real-time synthesis. And so what it allows is to create customizable voice agents. What it means is the same way you can change the personality of a text model, now you can change the personality and voice of any voice agent very easily. That gives a scope that is extremely large. Among our first customers, we have video game developers that make NPCs, that make e-sport commentary. We have customer support. We have media groups that create personalized media content that fits your interests. We have application in restoration of voice for people who are suffering from neurodegenerative disease, digital advertisement. So the scope is extremely large. And in any case, people always want the same thing. They want the customization. They want high quality for voice, and they want to have a good interaction.
So now it's possible for them, if they've already worked on LLMs and agents and they already have a basis, to add your technology on top of what already exists very easily.
Absolutely. So you can take any off-the-shelf or custom LLM already connected to your databases, your function calling, and so on. And we become just a voice wrapper around it that turns it into a voice AI.
And it's going to be a huge gap in quality compared to maybe other voice models that are out there.
So if you look at the market for people who make voice models, it's actually pretty small. And interestingly, people are either typically specialized in making synthesis or making transcription. What we have learned along the years and developed in particular at Qtile is audio foundation models, where we completely master the full stack of audio, from transcribing, translating, synthesizing, improving audio, transforming audio. And so we have this kind of ubiquitous abilities in audio based on our deep technical understanding of audio models.
That sounds amazing. Maybe it's something that we could show to the people who haven't been on your website yet?
So we try to make, it's like our culture at Qtile now, also at Gradium. We are kind of addicted to live demos without any safety net, so we're going to do it again today.
Let's try it again.
One big application that we see upcoming for voice AI is that we see, and we had a very nice robot earlier, robots, including humanoid robots, are going to be in factories, are going to be in homes, are going to be in our society. And in that context, more than in any other, the interaction will naturally go through voice in complex environments with background noise and so on and so forth. And so today with me, I brought a small friend.
Let's show it on stage. All right.
It's a Richie Mini small robot from our friends at Hugging Face. And what we did is that we connected our API for speech-to-text and text-to-speech with an open source LLM. And that allows to have kind of a conversation with the robot.
Let's do it. It's booting.
Hi there. I'm the Gradium Voice AI, here to chat with you in any tone or language you like. Need a different voice? Just ask. Want me to show some emotion? I've got you covered. What's on your mind?
Maybe you can start by telling us a few things about yourself.
I'm your friendly Gradient Voice AI, powered by real-time speech tech and embodied in the Reachy mini robot. I can switch voices, accents, and even emotions on demand, like going from cheerful to thoughtful in a heartbeat. I speak English, French, Spanish, German, and Portuguese. And yes, I blink, gesture, and move my antenna to match how I'm feeling. Want to see me in action? Just say the word.
Okay, maybe you can do something a bit fun. I want to get, to improve my health overall, and so I'm looking for a bro to go to the gym. Can you take the personality and the voice of a gym addict?
Hey, I'm Logan, your gym bro. Let's crush those gains together. You ready to lift, sweat, and feel awesome? I've got your back, no excuses, just results. What's your goal? Strength, size, endurance? Let's make it happen.
Actually, it's a bit more personal than that. I'm always too shy to dance. I'd like to learn how to dance. Maybe you can make a small demonstration.
All right, let's get you moving. First, stand tall, shoulders back, hips loose. Now step side to side, bounce with the beat. Don't think, just feel it. I'll count 1, 2, 3, 4. You got this, let's groove.
Okay, pretty cool. One thing when we did Moshi is that people were really looking forward to having other languages supported. So maybe from now on you could chat a bit in French, and to show the diversity of accents and so on, maybe you can do that with an accent, a Quebec accent from Canada.
Salut! Je suis Alain, ton pote de Québec. On va danser en français maintenant, c'est ça? Allez, bouge les hanches, respire et laisse la musique te guider. Tu veux qu'on essaie un pas de salsa ou un peu de hip-hop? C'est toi qui choisis.
Okay, maybe we are going to forget a bit about the dance right now. What can you tell us about? I just want to know your thoughts about how AI and voice AI, covering a lot of languages and accents, can improve communication between humans and machines and between humans overall.
C'est une excellente question. L'IA vocale, surtout quand elle parle plusieurs langues et accents, brise les
Wait a
barrières.
minute. Actually, our audience is globally international. Can you repeat that, but in English, please?
That's a great question. Voice AI that speaks many languages and accents breaks down barriers, not just between humans and machines, but between people too. It lets someone in Tokyo chat with someone in Montreal as if they're in the same room. It makes tech feel personal, not robotic, and that's how we build real connection.
Well, that was very deep, Richie Mini. I think a lot of food for thought for all of us. Thanks a lot. Have a good one.
Thanks, Richie.
You're
so
welcome.
impressive.
I'm glad I could help. Stay curious, stay connected, and remember, whether you're dancing, lifting, or just chatting, I'm here for it. Have an awesome day. Bye.
That's the less erratic live demo we've ever had. Great job.
This was completely unscripted, so...
Impressive, really impressive. I know what's even more impressive to me is that even though you announced the launch only this week, you had assembled the team and the investors only 3 months ago. And so I think this is a record. And this is also due to the articulation between the research in Qt and then spinning off into a company. What do you think about this model? Is this something we could replicate?
Yeah, so as you just said, what we announced 2 days ago is not just the fundraising and the incorporation of the company, it's our first product. So what you just saw, you can use it for our API, you can use it for voice agents, you can use it in robotics for any kind of application. And what allowed us to execute with such a velocity, so being able to train, because we are fundamentally a foundation model company, train models from scratch, build an infrastructure, and create models that run in production after only a few weeks. It's a lot thanks to the momentum we had accumulated at Qt. So, in a way, Qt allowed us to find our product market fit in such a natural and organic way. It was not the original plan, it's just when we saw so much traction from the market, and we are talking about gigantic gaming opportunities in businesses and so on, that we had to
and
seize
you already
this
have real customers, right? So
yeah,
it's true.
we have actual customers. Hundreds of thousands of phone calls are powered by our models and NPCs in video games and so on and so forth. And so I think, and I hope for Qt to also see this kind of model happen again in the future, where through open research and fundamental research, not only value is created by knowledge that is shared publicly, but also by, emerging and finding ideas for our new products. Because in a way, what we were able to do at Qt, which is really pushing the scientific frontier of voice AI, it's because we had confidence in the model of Qt, that we could take risks, that we could take the time we needed. And so that put us in this position today, where we are on a path to become the world leader for voice AI. And that's our ambition, and that's our objective. And this comes from really what we have got from Qt. And Jan could tell it even better than I did. That's one of the big strengths of big tech. They have these fundamental research labs like FAIR, Google Brain, Google DeepMind, but they also have the product teams, and being able to have strong links between the two is something that is very valuable.
Right. And so I think it's important to reassure that Qt is not disappearing. If anything, we're calling out everyone to support Qt even more. They have a lot of ambition around new frontiers of AI, in particular world models. And so we hope to see this kind of pipeline of going from research to startups maybe happen again in the future. And you're an amazing example for this. Thank you. Maybe just to conclude on voice AI, because I'm curious, when we see this, it looks so well and functioning already. What's left to do, and why is voice AI so exciting today?
So where we're at right now is, we have this very nice way of creating instant voice agents where you can customize the voice, the personality, and so on. I think what eventually is going to be even more important is really pushing the boundary on naturalness. Now the latency is good, it can be improved, and we are going to improve it. Emotional understanding from AI is still pretty poor. We heard feedback from about all models in the market from a company that does AI therapy. And so people use the product, and then they start opening about personal problems. And maybe they're going to say, my dog has passed away, and the AI is like, oh, that's pretty sad. And this is just so inappropriate. So having AI that understands the emotional context, that reacts in a way a human will do, I think is a big frontier. And then, when we think about robotics, imagine that you have a robot in a factory that needs to interact with a lot of people who shout from various distances with machinery, noise, and so on. This is completely out of the picture today. Nobody can build such a thing. And that's the kind of challenges we are working on as well at Qt and Gradium, which is speech interaction, not in a clean setting, even though it's a challenging setting on the stage, but in very complex acoustic scenes where a lot of people are going to talk, and you need to keep track of what was said by whom, and so on and so forth.
Well, thank you. I think what we're taking away from this is that voice AI's potential is incredible. I imagine a lot of people want to join your team if there's room. And also what I would recommend for everyone is, go on Gradium's website, contact them. There's so many applications behind voice technology, it's amazing.
Yes, we're ready to be put in production today, so please reach out if you are very talented and you want to join the best voice team, join us as well. A final word, thanks to my friend Alex, who helped me make this demo today, so yeah.
Thanks, Alex.
My friend and Chief Science Officer of Gradium also.
Well, thank you very much, Neil, for this clear overview of Gradium. Thank you. See you soon. All right. I think our morning session is already coming to a close. But there's more ahead this afternoon. We'll continue to explore AI as it grows smarter, faster, and everywhere, with some leading experts in the field. You'll be able to take part in some very deep technical panels, but also very hands-on workshops. We'll kick it off at noon with my dear friend, the amazing Steve Morin, the founder of ZML. He'll be on the master stage behind you to discuss optimization of inference at scale on various hardwares. And then at the same time, at the Founders Cafe, you can meet Alexandre Thomas, who's the VP of Engineering from AVE. He will help you learn about the mechanics of next-gen video creation. Again, we have a really full program this afternoon. I do encourage you to check it out. And in the meantime, thank you for joining us today, and I'll see you next year. Bye.